Welcome to CodeChef. Today, we are going to learn about merge sort, an efficient sorting algorithm that follows the divide and conquer approach. Merge sort follows the divide and conquer paradigm, which consists of 3 steps. First, we divide the array into 2 halves. Then, we recursively sort these halves. Finally, we merge them back together in sorted order. Let's see how merge sort works in action. Consider this unsorted array: 64, 34, 25, 12, 22, 11, 90. First, we divide the array into 2 halves: 64, 34, 25, 12, and 22, 11, 90. We continue dividing until each element is in its own subarray. Now each element is a separate array, and we are ready to start merging. We start merging adjacent elements while keeping them sorted. 64 and 34 merge into 34, 64. Next, 25 and 12 merge into 12, 25, and 22 and 11 merge into 11, 22. The number 90 remains as it is. Now we merge 34, 64 with 12, 25, arranging them in sorted order to form 12, 25, 34, 64. Similarly, 11, 22 merges with 90, forming 11, 22, 90. Lastly, we merge 12, 25, 34, 64 with 11, 22, 90, arranging them in order to get our fully sorted array: 11, 12, 22, 25, 34, 64, 90. And that's how merge sort works. It efficiently sorts an array using the divide and conquer technique. The time complexity of merge sort is O(n) log n in all cases: best, worst, and average. This is because the array is always divided into halves, and merging takes linear time. Merge sort is also a stable sorting algorithm, meaning that it maintains the relative order of equal elements in the sorted array. Thanks for watching. Keep learning with CodeChef, and happy coding!